I'm doing my usual CHEM 1065 lecture video about how to work up all of your data for the food dye lab, but this video has been updated for fall 2025. We switched out software, so my old one just has some different things. The very first thing that I want to do is walk you guys through how to use the dilution equation in order to find the concentration of the solutions that you made in lab, because we'll need that to make our calibration curves, which we're going to do next. If you're comfortable with the dilution equation and you've already done that, you can just ignore this part of the video and fast forward until I start talking about Excel spreadsheets. Okay, when we were in lab, we had some beverage and it had 2 food dyes in it. And we maybe made different concentrations of red food dye. We made a few different concentrations of red food dye. And maybe if our drink was purple, we made a few different concentrations of blue food dye as well. You'll need at least 3, but 5 would be ideal. And so let's say that each one of these concentrations is going to be 1 point on our calibration curve. So if we have like 1 ml red, 4 ml water, maybe we had 3 ml red and 2 ml water. And then we had some other concentration. I'm just going to say concentration for all of these. So all of these are different concentrations. It's like concentration 1, 2, 3, concentration 3. And we need to calculate for each one of these the concentration that it is. So for right now, just for our practice, we want to know the concentration of this one. So this is the one I'll be working with. What is its concentration? Okay, so when you were in lab and you made this solution, you took a beaker and then you took the stock solution dye. So maybe this was red number 40 that was available in lab. Maybe its concentration was like 10 to the -6 molar, right? So you took this and you took 1 milliliter of it and put it into your beaker. And then maybe you added like 4 milliliters of water into your beaker as well. So we mixed those together and we made a solution. And because we added 1 milliliter of dye and 4 milliliters water, the entire thing is going to be 5 milliliters. And you repeated this process for every single one of these solutions. But again, for right now, we're just working with one as an example. So in order to figure out the concentration of this, we're going to use the dilution equation. And the dilution equation says that M1V1 is equal to M2V2, where M is concentration in molarity, and V is volume. The hardest part of using this equation is just assigning the variables. So when we assign our variables, what we're going to do is we're going to say that the concentration of the dye that was in lab, so the thing that we started with that you pulled out of the stock bottle, that's going to be our M1. And then the amount of it that we added into our solution is going to be our V1. And that makes sense. We have a concentration and a volume of the same thing, and we added them together. We don't know the concentration of this. This is what we're trying to figure out. So that's going to be our M2. And that's going to be our variable. V2 is tricky because you have to remember that the total volume of the whole solution that you made, the dye plus the water, is V2. The 4 milliliters of water is not the V2. So you have to know how much water you added so that you can calculate V2, but the amount of water added is not V2. The variable you use is the total volume of solution. Now that we've assigned all of our variables, we just plug everything into our equation. And so we say our M1 was 10 to the negative 6 molar. V1 was 1 milliliter. M2, I'm just going to leave as a variable. And V2 was 5 milliliters. And then it's just algebra, and you solve for M2 equals 10 to the negative 6 molar times 1 mil divided by 5 mil. And when you plug this into a calculator, you'll get some number. That will be your concentration in molarity. Units of milliliters cancel each other out. And that leaves you with molarity for your answer. So number with units in molarity. So you'll go through and you'll repeat this process for every one of the red dye solutions that you used. And then you should make yourself a table in Microsoft Excel. And you should say like red dye solution. 1 mil red, 4 mils water. 2 mils red, 3 mils water, so on and so forth. And for each of those solutions, when you were in Vernier, you got some absorbance. And you'll say, okay, for this, and in Vernier, I mean like you got on your spectrum of absorbance versus wavelength, there was some peak, and then you like selected a region and you hit view statistics and it gave you a max. That's the absorbance value that I want you to use. So you'll write in your absorbance, and I'm just going to write in A's because I don't have these off the top of my head. And then you will write in the concentration that you just calculated. And do this for all of your red dye solutions. And then repeat this for your second dye. Or if you didn't use red dye, do this for each of the dyes that you did use. Okay, so once you've got all of your calculations with your dilution equation done, and you've calculated the concentration and absorbance for all of your dyes, you can go on to making a calibration curve. And I am going to walk you guys through how to do that in Microsoft Excel. So in Excel, you basically put down that table that I was just talking about where you wrote down the solution, the concentration, and the absorbance. You just type all of those numbers into Excel. So I've got a column for my concentration data and a column for my absorbance data. There's one thing I'd like to know. Let's say you have a concentration and your concentration is something like 7 times 10 to the power of -3. In order to actually type that into Excel, Excel can't read numbers that look like this. So to type this into Excel, what you need to do is hit the equal sign. Then you type in your first number, so your 7. Instead of typing times 10 to whatever power, we type an E. And what the E says to Excel is like exponent, like 10 to the power of something. We have a -3, so then we type in -0.3. So all written out, it looks like that. And I told Excel not to actually carry out the math on this function. So if you were to just do 7E -0.3, you could see that it converts it to the proper decimal. If you typed in equals 7E +3, it would convert it to 7,000. I think if you go like large enough, it will just leave it in scientific notation. Like that would be a lot of zeros. But so that's a note about Excel and how to type in numbers. And then one other note, absorbance, I've written AU for the units. That stands for arbitrary units. So from here, we're going to go ahead and we're going to actually make our calibration curve. So I'm not going to select any data. I'm just going to go up to the insert button at the top of my screen. And my mouse is large and pink, so hopefully you're able to follow along with where my mouse is going. So I'm going to insert at the top of my screen. I'm going to come over here to the charts, and I'm going to look for the scatter plot. There's a drop-down arrow next to it, so I want to click the scatter plot. And I'm going to click the dots with no lines. So I've basically created a really giant empty chart right here. What may happen is you insert a chart and it's got a bunch of random data on it, and that's wrong. And if that's the case, click on your chart and click the Select Data button. There will be a data set here. It'll be selected and you'll just hit Remove. If you're on a Mac, you might have like a plus or minus button here and a list of data sets, and the plus is Add and the minus is Remove. Once you've removed any data that's not helpful to you, you go to Select Data, and this time we're going to add data. And so the box that comes up says series name, and I'm going to call this green, ooh, whoa, green thigh calibration curve. Sorry, I'm not really sure what just happened there. My computer did something weird. Okay, it doesn't matter what you name it. You could keyboard smash, that would be fine. Series X values and series Y values, if there's anything written in either of them, you can just delete it. Are where you select, okay, that's why that's written in there. I made it angry. Okay, I'm just gonna select my Y values first. So remember, for a calibration curve, you want to have on your Y-axis your absorbance values. So we're gonna tell it on my Y-axis for series Y values, put absorbance. So I just go over to my absorbance values, I click and drag to select all of them, and Excel automatically figures out how to code that. Let go, and it puts it in your box. For series X values, we do the same thing, but we want concentration on our X-axis, so we select the concentration data. Then you hit OK, and OK again. What I was talking about earlier with deleting data, you go to select data, and you could hit the remove button, and that would delete the data from your chart, and then you would hit OK. But I want the data there, so I'm going to hit cancel. Oh no. Okay, well, it did not like that, so we're just going to redo that real quick. So X values are the things that go on the X-axis. Y values are the things that go on the Y-axis. Okay, okay again. And there's my calibration curve data. So this is great. Our data is on the curve, but now we need to get a line of best fit in order to actually use this calibration curve. So I'm going to do a couple of things. I'm going to go up here to add chart element, and I'm going to click on the box that says trend line and linear. Then I'm going to double click on my trend line, and you'll notice a box that pops up off to the side of your screen. And this is when you're on your trend line, this box will pop up. So you will notice this like paint bucket, this pentagon, they all do different things, but we want to make sure we're on the tab with the 3 bars. We're going to scroll down to the bottom, and I'll pull this over so we can see it a little bit better. And the first thing you want to do is check the box that says set intercept. This is how we're going to tell our calibration curve that the line needs to go through 0 when there's 0 dye in there. So we click set intercept, and it already says 0, but you could change the value and type in 0 if it didn't. In addition to that, we're going to check the box that says display equation on chart. And this is great. This is the equation that we needed for our calibration curve. So I'm going to close out of this box and real quick show you how to do a couple of other things that are helpful for your calibration curve. Again, we're going to go to add chart element. We're going to add axis titles. I'm going to add vertical and horizontal axis titles. We want all of the axis titles. I'm also going to go here and I'm going to get rid of the grid lines. Let's see. So it wants me to get rid of the vertical and the horizontal separately. So the grid lines are gone. And I'm also going to get rid of the title, the chart title, because when you're writing a lab report, we put the chart title in the figure caption. So now we can just go type into these boxes, and I can say that this is absorbance in arbitrary units. and this is concentration and molarity. And if I wanted to, I could double click on my equation and I could move it somewhere. But this is it. This is your calibration curve. One reminder, you have an equation that says y equals, from your calibration curve, and yours will be different, 43,658 x. On our y-axis, we have absorbance. And on our x-axis, we have concentration. So we can rewrite this equation to say absorbance is equal to 43,658 times concentration. And that is how you will use your absorbance data to calculate your concentration data. There's one more thing that I'm going to do. If you had your data on a Google Sheet, you want to move your data into Excel. And you can just copy and paste it, but that might take a while. So if you're on your Google Sheet, you can hit File, Download, and download as a Microsoft Excel file. And then you can open that file and work in it. I've already done that. And this is the Excel file that I downloaded. So the last thing we're going to talk about is how to make a spectrum and how to recreate the spectrum from your absorbance and wavelength data. So this time, once again, we're going to go into Insert Chart and the scatter plots. This time, I'm going to choose this smooth line scatter plot, and I'm going to add that. And this is a really good example of it just kind of put in some random data. So we need to go to Select Data and remove that data set. So now we have a blank slate to work with. Once again, I'm going to select data, and this is where I'm going to add my series. So this will just be one individual spectrum, and I recommend you name it like 1 mil dye, like green dye, and 4 mils water, just so you can keep track of it. On the X values, you want to put in all of your wavelength data. For a spectrum, we want to have the wavelengths. So we're going to go over here and click and drag all of our wavelengths. And the good thing about Excel is it starts slowing down when you get near the end, so you don't just fly right by it. Scroll back up to the top. Delete what's in the series Y values. And then remember on the Y-axis goes absorbance. So we're going to select all of our absorbance data points. There we go. Then we're going to click OK. And OK again. Scroll back up to the top where our chart was. And we now have our chart here. So this is our spectrum, and that's awesome. And I'm just going to walk through a couple things that are going to make it look a little bit nicer. So once again, if I've selected my chart, I'm going to go to Add Chart Element. And I am going to get rid of the grid lines. Turn off the vertical, grid lines, turn off the horizontal, because I don't like the way the grid lines look. I'm going to add axis titles for both of my axes. And then you would, just like the last one, click into them and name them whatever. In this case, you're going to name them wavelength, and that's measured in nanometers. And then the y-axis, again, is going to be absorbance in arbitrary units. And then I want to do a couple more things. One, this is kind of a silly, goofy chart title. So I am going to remove my chart title. Two, I've got some axes that don't make a lot of sense. I've got a whole lot of blank space over here, and then this one goes negative, but there's nothing there that it's plotting. So once again, I'm going to go into this box on the side of my screen. So I'm going to double click on my axis. Maybe. There we go. Double click on your axis. You should see that like rectangle box pop up. Where it says axis bounds, see how it says 0 to 1,000? That's telling me that this is going from 0 to 1,000. But that's not my data range. So instead of starting at 0, I'm going to tell it start at 300. And that looks way better. Now I don't have as much white space. I've got a little extra room on the ends. I like the way that looks. So now I'm just going to double click on my other axis and I'm going to change that. And I want my lowest absorbance to be 0. And you can leave the maximum roughly where it is, or you can change it to 1 because that's the highest absorbance that you can get. And you can see, there's some white space here. So this only absorbed about half of what it should have. Or you could just leave it where it is. But this here is your spectrum for that one dye solution. And you would make all of the spectra the exact same way. So I'm going to stop sharing. So in this video, we went over the dilution equation to calculate your concentrations, how to make a calibration curve, and how to recreate your spectra using Microsoft Excel. Remember for your lab reports that screenshots are not accepted. So you'll have to recreate your spectra in Excel if you want to do that. Thanks, and let me know if you guys have any questions.